particle is projected from the point with position vector 3i plus 3j meters relative to a fixed origin O, where I and j are unit vectors in the horizontal and upward vertical directions respectively. 2 seconds later the particle passes through the point with position vector 13i plus 8j meters. We want to find the initial velocity vector. So we know this particle is projected, so it's a projectile. And if we call this v and theta, then the speed this way would be v cos theta and v sin theta. If we think about the distance travelled, there's no acceleration horizontally, so that's just going to be vt cos theta. Now, don't forget we start here, so that would be plus 3. And then for the y, we'll need to use ut plus a half at squared, so that will be vt sine theta. And the acceleration will be downwards 9.8, half of 9.8 is 4.9, so that's minus 4.9 t squared. And don't forget that we start here, so we need to add 3. And then when t is 2, it goes through this point. So, in other words, 13 is equal to, so t is 2, 2v cos theta plus 3. So 2v cos theta would be equal to 10, giving us v cos theta is equal to 5. Now going to here, so we've got 8 is equal to 2v sine theta, and we're talking about when t is 2, so 4 times this, so let's take away 90.6, add 3. So 2v sine theta would be, so this is negative 16.6, add that onto 8, would give us 24.6. And so v sine theta would be 12.3. Now, this is the initial velocity, and this is the initial velocity upwards. So we can say that v of 0 is 5, 12.3. Assuming the ground is where the j component of position is 0, find the time of flight of the particle. So that's going to be, this is the j component, so we want where that is equal to 0. So, what have we found so far? Well, we know that v sine theta is 12.3, so that's going to be 12.3 t, take away 4.9 t squared plus 3 is equal to 0. So we can solve that on the calculator. Action, advanced, solve. 12.3 x, take away 4.9 x squared plus 3 is equal to 0. And it might have been better to be in decimal. And obviously we don't want the negative result, so we're going to take the 2.734 and so on. So we'll call that t is 2.73 seconds, correct to 2 decimal places. We now want the speed with which the particle hits the ground. Now, our velocity vector will be got by differentiating this with respect to t. So v cos theta, which of course we know is 5. And then we have 12.3t take away 4.9t squared plus 3 here. We need to differentiate that, so that would give us 12.3 take away 9.8t. So we want v of 2.734 and so on. Well, obviously this component won't change, and so we want 12.3 take away 9.8 multiplied by this number just over here, and that gives us negative 14.49 and so on. And so the speed is just going to be the square root of 5 squared plus 14.49 and so on squared. So we want the square root of this squared, add 25, that gives us 15.33. So let's call that 15.3 meters per second and just say that's to 1 decimal place. Finally, we want the angle at which the particle hits the ground. So we know it's going 5 across and 14.49 and so on down. So this is when it hits the ground, and let's call this the angle theta. So we can say that theta is going to be the inverse tangent of 5 over 14.49 and so on. So we want the inverse tangent, and 5 on the top, and this number here on the bottom. And so that would give us 19.0 degrees to the vertical.